All right, let's take a look at this problem. I think it's pretty straightforward, but let's make sure we don't screw it up when we do this. It says let F1 be the magnitude of the force. F1 is the magnitude of the gravitational force exerted on the sun by the Earth. And F2 is on the magnitude of the gravitational force on the Earth due to the sun, so by the sun. Well, I know that my gravitational force in general is going to be equal to G m1 m2 over r12 quantity squared. My subscripts 1 designate mass 1, mass 2, and the distance between mass 1 and mass 2. And this is the magnitude of the force. Well, if I look at this, when I do F1 then is equal to G m of the sun, mass of the Earth, over the radius from the sun to the Earth squared. And F2 is going to be G m of the Earth, mass of the sun, times the radius of the Earth to the sun distance. While G, M, S, M, E both are in both cases, and I have this radius of the sun to the Earth and a radius of the Earth to the sun. The values are squared. It's a magnitude of them. So these two values are exactly equal to each other. The real difference between the two of them is they actually point in opposite directions. The sun is going to try to pull the Earth to itself. So the Earth is going to be pulled in that direction. So that's F2. And F1 is going to be pulled in that direction. You got to remember that we're dealing with forces. We're not dealing with the acceleration. The sun has a really, really large mass. So if it feels this force, it's not going to move nearly as much as F2 will, because because the Earth has a much smaller mass. Its inertia is much, much lower. So a pretty straightforward problem. Just have to watch our subscripts. Make sure that we don't screw them up.